Hi, this is Junaid, neurocritical care stroke and epilepsy specialist. Last time we discussed Chat GPT 4, mainly their technical report. This time we're going to discuss Palm 2. In the coming lecture, we're going to discuss mainly the Palm 2, which is their fine-tuned model for biomedical science. Let's start. Hi, this is Junaid. So the large language models, one of the essential things are foundation models. These foundation models are essential for creating different attributes, different ways of fine-tuning for your data. So for example, Palm 2 is actually, that we're going to discuss the technical report right after this, has already created a super-tuned, hyper-tuned, fine-tuned model of biomedical research. Same thing can happen with GPT-4, the fine-tuning can be done. But not only that, this battle is absolutely heating up. One of the key contenders are, of course, OpenAI, which I'm going to call it Microsoft at the end of the day. I don't see any difference between the two anymore. As a matter of fact, if you look at the last lecture, it happened yesterday, that Microsoft build was announced 2023, and you can see that everything was about Copilot, and all the Copilot was built on GPT-4. Same thing will happen with Google. Everything they're doing is going to be now built on Palm 2. As a matter of fact, they're reintroducing everything in their I/O, in which they're going to make everything based on artificial intelligence. And then, of course, there are other contenders in this space. One of the big ones is Claude AI. Interestingly, this is from a company called Anthropic. And that Anthropic, interestingly, Google owns 10% of that company already. And they just, I think Series D or Series C, I forget, and raised $450 million again for their large language foundation model. And then lastly, we have Meta, and believe it or not, Meta is a big elephant in the room as far as artificial intelligence is concerned. They don't come out as an artificial intelligence company, but their core model, their artificial intelligence, drives their advertising business at the very core. As a matter of fact, once they have started recently updating their all advertising business through AI, their stocks have gone higher. They're getting more results from the all of these campaigns and everything. So as soon as they have introduced more fine-tuned artificial intelligence within their advertising business, they're going to do. They introduced Llama. Again, it's a 65 billion parameter. I may or may not go into the whole details of it, but again, this is one of the contenders. And interestingly, IBM, which used to be somewhere what we call Watson, which is specifically designed for question and answering, and then eventually used for oncology a lot in medicine, have announced that they're going to release Watson X. And Watson X is another large language model that is going to be available on the same footing, mainly as an enterprise offering. So this is what we call the large big tech companies and their offerings. Interestingly, the big elephant in the room is still missing, and that is Apple. Now, where is Apple? I don't know. What are they going to do? I don't know. But believe it or not, they were first into this conversational artificial intelligence with Siri back in 2014. The whole idea was eventually that you will have voice conversations with your devices, and that's why they bought Siri that long time ago. Unfortunately, it didn't go anywhere. It wasn't a priority, I'm assuming. Their overall idea behind putting artificial intelligence is, of course, safety, because they really do care about that, and privacy. And I think that's why they're going to come late to the party. And then second of all, the most important part about this Apple is that it is a consumer based, and designing something for consumer level is very relatively much harder as compared to for enterprise, because enterprise people have technical people, they can fine tune their models accordingly, all of that. So with that longer overdue, let's just talk about Palm 2. Now, Palm 2 is the latest offering from Google, clearly. As you can see, Google has not been quiet, and as a matter of fact, essentially pissed off what OpenAI and Microsoft has been doing, and they are coming out with gloves off, and they have been making significant strides in their artificial intelligence. Not that they didn't have the capability. I think they were a sleeping giant, and Microsoft kicked them to the curb and say, wake up, buddy. And as a matter of fact, if you look at Satya Nadala's interviews, he said, we made Google dance. And literally, that's what it is. We made them come and dance. And that's one of the features that they're looking at as far as making sure that this is it. Now, clearly, Palm 2 is an upgrade on Palm 1. Palm 1 was even a bigger model. I'm going to go ahead and go through that. It is the state-of-the-art language model, which is better by multilingual. And that is completely true. Now, Google's overall is a search company, right? Google is a search company and an advertisement company. Actually, I should call it an advertisement company. But at the end of the heart of their business is search. For search, there are two important things. One is multilingual capacity, so that anyone, because they serve 2 billion people a day, so they want it to be multilingual. So multilingual is at the core of their offering. And number two, of course, is accuracy. Now, Bard didn't care much. Bard does care about it. OpenAI didn't care too much about accuracy. They were creating a generative large language model for anyone. Then you connect it to Bing and get the most updated, accurate results. Then you connect it to Wolfram Alpha to get the best mathematical results. They wanted to create only a big, basic, beautiful foundation model. Google has a different offering. Google is essentially a search company, which is now, quote unquote, they're calling it an AI company or an AI first company. That's the term you use, AI first company. And the reason behind that is that they need to be more accurate because their whole business model depends on it. Also, if you're going to generate everything, what the hell is people going to search for? If your Bard is going to be able to do everything without conversation system, their whole business model fails. So therefore, they have to be very, essentially much more different than Chat GPT, both in terms of multilingual capacity, in terms of accuracy, and more importantly, making sure that advertising business doesn't get swallowed up by this. Microsoft doesn't care. The Bing barely runs for $100 million. Their whole core business model is completely different. Where they get the money from is very different. So therefore, they don't care if Google comes and dies, because their whole point is essentially kill Google, right? Because that's one of the things that really pissed off Microsoft back in the day. Anyways, PaLM 2 is a transformer-based multilingual language model with reasoning tasks and demonstrates a significantly improved quality on downstream tasks. Now, this is very important. Whenever you're designing foundation models, you don't care about, like, okay, great, you've got a fantastic foundation model. What are you going to do with it? Eat it in your kitchen? No, you need a back-end task that they are doing. And therefore, foundation models need to be better at doing downstream tasks, simultaneously exhibiting faster. And this is very, very important. Again, if you're serving 2 billion people a day, you have to make sure that this is actually low latency and more efficient inference. Why? Because these cost GPUs. Again, if you're building 2 billion, serving 2 billion people a day, you need it to be extremely efficient, because if you're going to do it for free, you're eating up your margins. So therefore, their whole idea behind PaLM 2 was essentially to make sure that it is a faster, more efficient model, and it's therefore smaller size. As a matter of fact, if you look at the whole presentation that they went through, interestingly, you could see that they had actually 5 different sizes of the model itself. The smallest one being Gecko, and the largest one was, I think, PaLM 2, which was, again, named Unicorn. Interesting name choices, I suppose. So they called it the Unicorn. But either way, all the way from Gecko to Unicorn, they were able to give different model flavors, again, making sure that their enterprise offering has a slew of offerings in terms of device sizes, large language model sizes. Therefore, their customers can use this exact thing on multiple models. Again, this is not available. I've also personally applied to get the API access. Anyone from Google, please give me access so I can start testing it. Anyways, the idea behind it is that they are actually looking at exhibit stable performance on suite of responsible AI evaluations. This third responsible AI evaluations, honestly, I'm going to do a whole separate video about what is explainability in AI, what is transparency in data governance, what is data governance laws, what are these different models are actually using for the data, etc. And if you're really interested in it, just leave me in the comments so I can make it a little sooner. It takes a lot of research to do that. Essentially, they did achieve a state-of-the-art performance across diverse set of tasks and capabilities. Again, I'm good. The way I do these is basically to make sure that you understand the highlights of this document. I would highly recommend anyone who's interested in fine-tuning a model, making sure that at the end of the day, the whole point I'm doing this personally is to choose a foundation model for my application, right? That's why I'm looking at all these options and then find out which option works best for me in my use case scenario. Again, it is not just about the capabilities, it's about the cost and latency, because believe it or not, if it's highly latent, one of the reasons that I don't like GPT-4 is because it takes much more time than Chat GPT. It's slower than GPT-4, and therefore I essentially try to use Chat GPT, and if I do not get an answer, then I switch back to GPT-4 because I'm just impatient. Anyways, so those are multiple factors that you're looking at when you are choosing a foundation model. And they go through a very good introduction. I think these are very important papers that they have referred to. I actually read, and interestingly, this has been going on since 1951, the large language models, and have shown strong performance. One of the things that when they were trying to introduce PaLM 2 was compute optimal scaling. Now, this is the key term that I told you before, that if they are going to use something that is going to be constantly being used billions of people, you want something that they scale, that can scale very rapidly and is very optimal in terms of compute resources that you use. Another thing they count is basically that they have improved data set mixtures. Again, there are two main important things, right? If you're going to ask about anything, there are two rate limiting factors. If I'm going to go build my foundation model, there are two things that are problematic. One is data, and not just data, high quality data. We have talked about this before in my prior videos, the 5 V's of big data, velocity, veracity, variety, etc. And all those data mixtures are extremely important to create these better large language models. Essentially, the more data is not essentially important, quality data is more important. Anyway, so they did what we call mixed data set. When you increase the data set variety, then you get better capabilities and therefore you get better outcomes. So one of the things they have been taunting about in this one is making sure that it is compute optimal, improved data set, and architectural and objective improvements. These is something that, of course, under trademark, and therefore I cannot speak too much about it, but they have actually looked at multiple different architectures and made sure they found the best one, at least as compared to PaLM 2, because they're mainly comparing it from their own previous version. Unfortunately, they didn't compare with Chat GPT or GPT-4. There are other people who are comparing it. I'm going to say essentially there is this, at this point in time, good or bad, this is 3.5, which is called Chat GPT, right? And then all the way into GPT-4. I'm going to rank MedPalm, right? PaLM, actually, not MedPalm, PaLM 2 over here. The PaLM itself was actually even worse than ChatGPT. So they have significantly improved it, but I don't think so they're all the way up to GPT-4 level as far as this is concerned. However, they're already announced that they're going to be training a model called Gemini. So once that Gemini is going to come, they're going to be essentially leapfrogging GPT-4, and hopefully by that time, I think GPT-5 will be announced. So again, we are looking at an arms race, which is going to destroy more jobs, honestly, at the end of the day. And I'm going to do another video understanding the economic impact of these large language models. This was a study by OpenAI, and they actually looked at all the different variations of tasks that we are doing. Again, I'll explain the difference between a job and a task, and how taking away the task essentially means overall taking away some jobs, but they use the word task. We'll go again in that video, so make sure you subscribe and like this video if you like it, because this will tell me that these are the kind of stuff that you actually like to listen. This is again unlocked by meticulous data selection and efficient architecture and objectives. This is one of the key things. When I'm fine-tuning my own model, which I'm currently doing, data selection is so much important. It is not just about having the core data source. It is how you embed that, how you actually make sure that those embeddings are actually perfectly tuned, how you actually make sure that the embedding model that you have used is actually, creating the results that you have. And there's honestly less science, but more art into it. And essentially, we have to do experiments after experiments after experiments. So we take a small data set, we fine tune it and see what it does, and then we change the result and then go from there. So it's thousands of experiments that are going on. And then, of course, you need human feedback to actually say that, okay, you know what, this is something that is actually truly there. So AI produces the result, another AI checks the result, then it goes to the human feedback. That's a whole loop. Again, we learned it from Anthropic, constitutional AI. Their main model of using was harmlessness. I use it for basically making more efficiency. But at the end of the day, those are things that those of you who are interested, especially in healthcare, for us, accuracy is very important. For us, efficiency is important. But most importantly, harmlessness as a constitutional, as a principle is very important. So that's why, honestly, out of all those ones, I am very, very impressed by Anthropic's Claude AI. At least their constitutional AI model for healthcare. Again, interestingly, okay, I'm sorry. Where's AWS? So AWS basically wants to offer everything. They don't want to create their own foundation model which they have is called Triton, and I'm not going to discuss that because they didn't release a technical report, and it is very, very, less obvious where you're going to use it in the grand scheme of things. Anyways, Anthropic is actually available via AWS. So that's another thing that where AWS comes in, is basically they don't want to disturb the market in terms of creating their own offering. I believe they are creating some offerings, but they want to basically be the reseller of all foundation models. Anyways, special canary token sequences were injected into PaLM 2 pre-trained to enable improved measures of memorization across language. Now, this key term, token size, memorization, etc., is again very, very important. Again, I'm going to come to Claude AI one of these days. They can actually have 10,000, 100K tokens. Memory is extremely important as far as when you have a large electronic health medical record, and how do you maintain memory so that you have this back propagation, which is the key where artificial intelligence works. You should be able to get better and better results and more, back end. I mean, this is literally the RAM in your computer. Everyone knows hard disk is one thing, but if you cannot actually bring that original data from hard disk to RAM and then analyze it, the RAM, this is essentially the RAM in a computer. Now, they actually did test it, PaLM 2 with PaLM 1, and as you can see on every language text, writing, another writing, this is French, Spanish, German, everywhere it did better. And then these are professional language proficiency exams, so therefore honestly they do much better as compared to even sometimes humans. And they have done a lot of fixing a bug with comments. They have used Korean over here as an example, and they're saying that you can have this multimodality. I use the word code, as I told you in my previous video. When you inject code into the training of large language model, the reasoning capability of the large language model becomes exponential, because the whole code is actually, at the end of the day, a way of reasoning things and defining, okay, define this, then this, then this. So therefore, if you are, let's say if I'm going to create a large language model specifically for healthcare, I'm going to get a code database to be injected into it, because that increases significantly the overall reasoning capability of a large language model. This is so great. I mean, honestly, this is superb. Explain this Persian proverb, and then they go into give me a Russian equivalent. And proverbs are very hard, right? And similar proverb, min jiddu wa jadda and min naimal mutabil bil matini. So interestingly, not only they were able to create Arabic proverbs, they were actually also he who strives finds, wishing does not achieve goals. Not only were they able to find the same proverb in Arabic, but also they were actually able to ask, can you give me a similar proverb? Again, mind-blowing. Honestly, everything. It's not just PaLM 2, it's the whole thing. And this is again the beauty of this particular thing is scaling laws. And they actually define two things, N and D. N is actually the model size and D is the training data. And they said that what they concluded, the power law that they say, the power law says that N, the model size, needs to grow at least as fast as the data. If you're going to put a large amount of data, you need to increase the model size as well. Model size means that the amount of connections that are in between these, so the convolutional neural network layers are actually higher, and therefore the connections between the neural network layers are higher, and therefore if you increase the data, you have to increase the model size. So therefore, that's why you have to really have to corroborate this and moving forward. Scaling laws, again, they had 4 different compute budgets, and they actually go through all of these and then define like optimal model parameters, token training tokens, etc., and then went into that whole thing of where is the optimal thing. Interestingly, DeepMind from Google, which is now officially back and completely into the Google, they actually did what we call Chinchilla. That was one of the most important publications. Again, these are more technical publications for people who are looking at actually building these, but for general consumers like me and you, and well, I'm somewhere between prosumer. But at the end of the day, what you're doing is understanding how these things are built, what their limitations are, and how you're going to use them, especially, let's say, in high stakes areas like law, healthcare, etc., so you understand that. This suggests that while scaling loss can be optimally loss for given quality, this does not necessarily transfer to achieving optimal performance of a given task. So this is something that they are looking at the downstream metrics as well. So not only they're looking at the scaling law, they're also looking at the downstream metric evaluations as well, and they did a lot of hyperparameter optimizations, etc., onto that. And again, everything is chinchilla optimal parameters, and they're looking at like what is the size. So over here they're actually going with that chinchilla model because they were actually able to calculate exactly what is the optimal size for the data to the model, and therefore that power law is being followed. We employed several data cleaning and quality filtering methods, deduplication, remove sensitivity of the PHI and stuff like that. And you can see observe significant improvement in English evaluation data sets, even though the data set for English was actually smaller than PALM initially. So PALM, their first version of the PALM 2, was actually more bigger in English, but in their current version, the English is less so. PALM's performance and exam designated for him as a standard academic machine learning benchmark. For exam, we focused on standard language proficiencies, and as I said, we showed it. English Q&A, classification tests, they did fantastic. If you look at reading comprehension, common sense reasoning, this is again used common, these are things that are used to test. So these are standardized tests now for different large language models, how they do it, etc. So if I'm building one, if I'm publishing something like this, I have to use these tests so that everyone can understand that if I say what percentage opened up, then you can compare it. Again, it's not apples to apples comparison because everyone doesn't use the same exact tests, etc. But anyways, all in all, this is important. What I was very, very impressed by the zero shot. Again, zero shot means that I give you one question and you get the right answer. And this significantly increased from 78 to 84. But if you look at 10 shot, interestingly, PALM 2 and PALM 1 are not that different. This is 86% and this is 87%. So if you sit there and actually teach the large language model exactly after 10 replies, you will be able to get better performance. Everyone wants to go to the zero shot because everyone wants to use these large language models as a Google search, but it is not Google search. It is essentially you're looking at generative AI, so you need to give them exactly what you want to generate. And again, one of those things that you get better is actually using prompt engineering. If you're interested, again, give me a comment in below, and then I'll make a video on exactly how to do prompt engineering. It significantly improved my results, so therefore I think this is something everyone should learn. All of these are tools. If you understand the tools, then you have to understand how you're going to use those tools and everything, right? I mean, from surgical instruments to EVD placement to central line placement, everything we had to learn. This is another tool that you have to learn to use it effectively. Anyways, put it in the comments if you're interested in a prompt engineering sort of primer. We evaluated PALM 2 on toxicity classification. Now, this is again essentially with Chat GPT 4. When I was talking about the technical report, they are actually, safety. These are things that they are also very interested in, is making sure that this is it. Again, I don't know how much it is. They're putting in some rules and regulations inside it. You can always jailbreak through it. There are multiple examples of doing that. However, rather than using the positive tense of the language, you can use the negative tense of the language and then still get the result. This is again an evolving field, and of course safety is a big concern. Clearly, large language models are not used for mathematical reasoning, and they also said that PALM 2 also struggles with quantitative reasoning as Chat GPT and GPT-4 does. And we can see that they are actually doing it. For them, the coding was actually an important task, and then they said that code languages models are among the most economic, significantly widely developed LLMs today, and that is so true. Because Copilot, Google's Copilot, which was based on ChatGPT, was fine-tuned for code. It's probably improved the efficiency of coding significantly. And they talked about code generation. I think that one of the things that their implementation is not just about code generation. They actually go back and refer to the original code in the GitHub so that you can actually go back. I mean, one of them is to, of course, give them attribute, because Apache 2 license and everything are important for attribution. But more than that, it is that I can go back where the original code was and see what libraries they have used it. So not just using that code snippet, I can actually go back and see which old libraries that were used, so that I can import those libraries within my application. So as far as the code generation, I am more impressed by Bard as compared to Copilot. Translation capabilities is where I would use PALM 2. If I have to choose a foundation model for generative AI, I would just use Chat GPT. If I have to use a foundation model for reasoning, I would use GPT-4. If I have to use a foundation model for translation, I would use Palm 2. This is beyond amazing as far as translations is concerned in general languages and in coding languages. So if I can say that coding language, and that's where its true strength lies, this translation capability. So if I have a code, let's say in JavaScript, and if I want to translate that into Java, or I have to translate that into C++, definitely the most important reason that I've been using is JavaScript to Python, right? And now I'm also using Rust personally within my team as well. This is just mind-boggling that I can just go in, give them a piece of code and say, translate into this language and put it in the code. Requires a little bit of debugging and it literally starts working. So super impressed with now what we can do, and honestly, it scares the shit out of me as far as the future is concerned. The few short regional machine learning translations in terms of Portuguese and Chinese, again, these are very different languages and they can actually do it pretty amazingly as far as this is concerned. Now, potential harms and biases. Regarding potential harms for dialogue, generative questions, answering in open label large language models, they did do a little bit of dialogue safety, again, bias risk, toxicity, prompts, etc., as far as that is concerned. And then they actually do go into racial biases, religious biases, etc., and they tell them exactly where the lines are drawn, etc. Again, these are things that we're going to parse out over a long period of time, how to manage bias. We all have biases. Humans have biases. That's why these large language models have biases. If we didn't have bias, they didn't care about bias. Anyways, this is their essentially their pitch of safety. Honestly, I cannot just pick this up and use in healthcare, right? I have to fine tune it. One of the reasons that I have to fine tune it is improve safety, because it's high stakes game. So again, you have to understand the limitations of these kind of large language models in terms of they can be fantastic foundation model, but essentially requires fine tuning. You need to do memorization is again one of the key passages that we looked at. Training corpuses, how are you going to use that, and then verbatim memorizations. They looked at multiple things in terms of memorization of tail, etc. Again, essentially what they're saying is that they improved the memory retention of this model, and this improved significantly the performance. And that is quite true. Again, it is not giving me the option because the token size is still small. I need a bigger token size because I need at least 75,000 words, basically, essentially, a full EHR put into the memory and then get the output. They use that technique to increase the training efficiency and therefore improve the output as much as they can. However, they're not giving me an option to increase the memory, just to let you know. And that's what I want as far as this models are concerned. Anyways, inference time control is again big thing, right? If we sample 500k prompts from this and simply follow those inputs, toxicity, probability, etc., and they also looked at 38,000 prompts. Again, I don't know what they are doing, but essentially this is old news because, as I told you, Anthropic is able to do 100k tokens, which is essentially 75,000 words. So they really need to step up their game, and they're doing it by releasing Gemini pretty soon as far as that is concerned. And one of the key things that they said, and they have published a paper of how to maintain memorization better, because as more memorization, as more back propagation, essentially the more data you can produce your generative AI on, that is much better. And you see all these prompts on Chat GPT out of memory, you have to decrease the size. That is something that is gone. So all in all, is a new state of the art. What I learned from this is very important. Is one, it is not just about the data size, it is about correlating with the model size. Number two, efficiency of both compute, and number three, latency is extremely important, and number four, memory. So idea behind all this video discussions and everything is to essentially understand where we lie in terms of this big picture of large language models and how it is going to change. I mean, the overall, one of the things that I've been noticing is the amount of progress in this less of a time is mind-boggling. And essentially, you know what we're gonna do is we're gonna do this one next. Let's do GPTs or GPTs, and this is actually an early look at labor market impact of potential of large language models is the next lecture. So you guys can understand as well that how it is going to impact everyone's life at this stage, and of course in the future, who knows. Thank you so much.